Okay, we're going to cover passage 5. This is a research passage. Research means read, so not carefully, just enough to know the difference between the two experiments. For our questions, we'll take the R and R approach, read, then reread the question, breaking it down step by step. So let's just quickly analyze the passage. We have spectrometry, and we have this letter in italics and parentheses. So we're looking at absorbance. So we have a beam of light, goes through something, and then we have a detector. So 2 experiments were performed on nickel, and it looks like we're doing 6 trials, nickel concentration, and testing the absorbance. What changes in experiment 2? Looks like they're changing the curvette width. In table 1, they're changing the nickel concentration. So nickel concentration to test absorbance, the cuvette width to test absorbance. That's it. Let's get to the questions. Which of the following variables was held constant, not changed, in experiment 1, but intentionally varied in experiment 2? So we know what changed in experiment 2 was the cuvette width, and that did not change in experiment 1. They were identical, so the answer is A. Number 28. The following table shows the wavelength ranges for visible light. So this is a new table. Based on the table, what was the color of light that came out of the light source? So it tells us in the reading that it was 710 nanometers. So 710 would make it red, so J. Number 29, consider the following steps that were performed in each trial in experiment 2. The steps were performed in what order? So we just got to decide what was done first. Was it place the sample in a cuvette, or was it place the cuvette in the spectrometer? And it tells us in the reading, right? They added the sample, the solution to cuvette first. So we know it's either A or B. So it's not C or D. Now we can see what was performed last. They measured the A of the sample, the absorbance. So your answer has to be B. Just approach that problem strategically. Number 30. Before the experiment, a student claimed that doubling the cuvette width between 2 trials will result in doubling the value of A. Are the results in table 2 consistent? So we're looking at table 2, and we see between trials 7 and 9, the cuvette width goes from 10 to 20. Between 8 and 10, it goes to 15 to 30. So we can compare either of those two. Now, if nothing else, we can eliminate choice F and H, because choice F said the cuvette width doubled from trial 7 to 8, and it didn't. It goes from 10 to 15, so that's a no. So we get it down to a 50-50 chance if nothing else. Then we break it down. We say from trial 7 to 9, right, the cuvette went from 10 to 20, and the absorbance went from 0.112 to 0.224. So yes, it did double. So your answer has to be G, yes. Choice J said it did not double in either case. We know it at least did in trials 7 to 9. We can verify that again by looking at trials 8 to 10. We see the same thing, it doubles. So your answer has to be G. 31, consider the charge of the nickel ion that was in the solutions analyzed. So it's Ni2+. To create a nickel ion with that particle charge, 2 subatomic particles were either gained or lost by a neutral atom. What were these particles, and were they gained or lost? So knowledge means that you know that the charge is based on the gain or loss of electrons. So C and D is out. And then if you're gaining or losing from a neutral atom to Ni2+, that means they were lost from the neutral atom, so your answer has to be B. What is the meaning of the value for the solution concentration that was tested in trial 5? So it's 18.8, which doesn't really help us a whole lot because we have 18.8 for all these. So what we need to understand more so is what does it mean to be a nickel solution, nickel aqueous solution, right? So nickel is solid, dissolved in an aqueous solution. So you can think of grams over liters as portion over whole, right? So 1 liter, the whole, contains 18.8 grams of dissolved nickel. That's the concentration of nickel in the aqueous solution. So F. 33, based on the results of experiments 1 and 2, did a greater amount of light reach the detector in trial 3 or trial 10? So if nothing else, right, we can say choices A and D are not true to the data. Choice A said the A for trial, the absorbance for trial 3 was higher than the absorbance for trial 10. That is not true. And you just look and say 0.195 is lower than 0.336. So again, we have it down to a 50-50 chance, B and C. Now this one you got to think about a little bit. It tells us what absorbance is. Absorbance is the measure of light that does not reach the detector. So on a time test, you're running out of time, this one might confuse you a little bit. So think about it this way. In trial 3, 0.95 does not reach the detector, so about 0.8 does. In trial 10, 0.336 does not reach, so about 0.7 did reach. We want to know which one had the greater amount of light that did reach the detector. That would be trial 3, so your answer has to be B. So here's your reporting categories. Look at the ones you missed and see if there's a particular type of question that might throw you off. Okay, reach out if you have any questions. Have a good day.